Hello students, today we will see Hill Cipher by using two examples having a key size 2 by 2 or and another example by using the key size 3 by 3. Now we will see this Hill Cipher, which is a classical cryptography method for encryption and decryption. Hill cipher is a polygraphic substitution cipher based on linear algebra. Now it's a polygraphic or polyalphabetic substitution. It means for occurrence of any letter, it may possible there is different substitution. For example, if the P is occurs more than once in a plain text, then it may be substituted by using alphabet. For example, suppose P is a alphabet in plain text. It may be converted into the ciphertext as A. It may be converted as S. It may be converted as X or in any form, and that is known as the polyalphabetic or polygraphic substitution cipher. That Hill cipher is developed by Lester S. Hill in 1929. It was first polygraphic cipher in which it was practical to operate on more than three symbols at once. It means it is a block cipher. Instead of converting one alphabet, it converts a block of letters, size of block depending on the key size. If key is 2 by 2 matrix, then the block of plain text is 2 alphabets. If it is 3 by 3, then the block is 3 or more. So depending on the key size, it converts that many letters or called as a block into the ciphertext at once. The formula used for encryption is C equal to K into P mod 26. K is key, P is plain text mod 26, and this is the formula for encryption. Decryption is reverse of encryption process, so K inverse C mod 26, where C is the ciphertext. So we are getting the plain text back by using K inverse C mod 26. Like the other digraphic ciphers, it acts on group of letters. Unlike the others, though it is extendable to work on different sized blocks of letters. So technically it is a polygraphic substitution cipher, as it can work on digraphs, trigraphs, or theoretically any size block. In particular, requires the users to have an elementary understanding of matrices. Now, in Hill cipher, there is a matrix multiplication. It means that this key is in the form of matrix. P also we require a vector matrix vector. So there is a matrix multiplication. Now the size of this P vector is depending on the size of K. K is always a square matrix, so K should be a square matrix. Now this square matrix may be 2 by 2, known as the digraph, 3 by 3, that is trigraph, or 4 by 4, it means it should be a square matrix. So depending on the size of, so if it is n by n, we called it generally as n by n matrix, then the plain text has to divide in the form of the n by 1 matrix. Then only it's possible to multiply that two matrices. So the size of P, we have to divide plain text such that we can create the columnar vector with n rows and one column. It uses modular arithmetic, as always we are multiplying it, or we are doing the operation, arithmetic operation mod 26 on this multiplication. So it is a modulo arithmetic. Because of this, this cipher has a significantly more mathematical nature than some of others. However, it is this nature that allows it to act easily on larger block of letters. So depending on this size, if our key matrix is more than 3 by 3, if it is 4 by 4, 5 by 5 or more than that, then accordingly we have to divide the plain text into the different size, into that n by 1 columnar vector. Now we will see the encryption procedure. To encrypt a message using Hill cipher, we first turn our keyword into key matrix 2 by 2. As I told you, it may be 2 by 2, that is digraph, 3 by 2 as a trigraph, or else. First thing, first step. Then second step is we also turn plain text into digraphs or trigraphs, and each of these into a column vector. So plain text has to be a column vector depending on this key matrix size. Next, third is we then perform matrix multiplication modulo the length of the alphabets, that is 26. So on each vector we are performing mod 26 operation. These vectors are then converted back into letters to produce the cipher text. So these are the 4 steps we have to apply on plain text. Then only it's possible, or that is the steps to convert the plain text into the cipher text. To encrypt a message, each block of n letters is multiplied by an invertible n by n matrix against modulo 26. To decrypt the message, each block is multiplied by the inverse of the matrix. So for encryption, we just multiplied it to vectors k and p, whereas for the decryption, we have to do the inverse of the matrix used for encryption. The matrix used for encryption is the cipher key, and it should be chosen randomly from the set of invertible modulo 26. The cipher can of course be adapted to an alphabet with any number of letters. All arithmetic just needs to be done modulo the number of letters instead of modulo 26. The key matrix must be a square matrix. As I told you, it should be a square matrix, and which is invertible matrix. I will tell you what is meant by invertible matrix also. Now, for example, key is blue. Now there are 4 letters, so it becomes a 2 by 2 matrix, and it is written as VIEW. Or it may be the quickness. Now here 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. It means we can create a 3 by 3 matrix. So this becomes a 3 by 3 matrix, and QUICKNESS. Convert these letters into the numbers, and this becomes our key. Now in the decryption process, we have to, in order to decrypt, we turn the ciphertext back into vector, then simply multiply by the inverse matrix of the key matrix. So first of all, we have, for the decryption process, we have to find out the inverse of the particular matrix. We must find the inverse matrix, then multiply the inverse by matrix by the column vector that can the ciphertext is split. So inverted matrix into the ciphertext column vectors, resulting we will get the back the plain text. So two complications exist in picking the encrypting matrix. The note this one, this is very important. Not all the matrices have an inverse. So whenever we want to decrypt the message, we have to require inverse of that matrix. And all the matrices are not having an inverse. So we have to select the matrix which satisfy some conditions. So the matrix will have an inverse if and only if its determinant is not 0. First condition, its determinant should not be 0. The determinant of the encrypted matrix must not have any common factor with the modular base. Meaning of this one is, if we are taking the GCD of what? Of this inverted matrix, of this matrix means determinant of, for example, K, determinant of K, if we are finding the determinant of K, mod 26, this one is one parameter for the GCD, comma 26. It should be 1. It means the common element between this and this should be. Thus, if we work modulo 26 as above, the determinant must be non-zero and must not be divisible by 2 or 30. So, it means in simple we can say GCD should be 1. If the determinant is 0 or has common factor with the modular base, then the matrix cannot be used in the Hill cipher. And another matrix must be chosen, otherwise it will not be possible to decrypt. So remember, this is very, very important in Hill cipher. So key selection is required. So fortunately, matrices which satisfy the condition to be used in the Hill cipher are fairly common. Now we will see the example. First we will see the matrix or the conversion process having the matrix 2 by 2 or the key size having matrix 2 by 2. Now encrypt the plain text attack. Now this is our plain text attack using Hill cipher having the key 2336. Now the key is given already in the form of the numbers, so there is no need to convert alphabets into the number. Directly it's given into the form of number, which is 2 by 2 matrix. As it is a 2 by 2 matrix, we require the plain text also to divide into the 2 by 1 matrix. So since the key is this one, so now our word is attack, that is the plain text. Now 2 by 1, it means divide this one into the form of two letters. So AT, TA, TA and CK. So these are our three groups, or this is a block. So alphabets 2 makes a one block. So and write down this as AT, TA and CK as a 2 by 1 column vector. Now first vector, take the first vector AT, which is converted into the numbers by using this conversion method, denoting method. So A is denoted as 0 and T is denoted as 19. And the key is 2336. As we are aware, the formula for Hill cipher is C is equal to KP mod 26. So take the key into P, that is this column vector mod 26. So 2336 key, this is our 80, 0 and 19 mod 26. Now do the matrix multiplication. So 2 into 0 plus 3 into 19. In the second row, 3 into 0 plus 6 into 19 mod 26. So here we will get 57 and 114 mod 26 as 5 and 10. So convert this 5 into the letter that is F and K. So our plain text AT is converted as FK as a ciphertext. So this is plain text and this is our ciphertext. Same method we will use for TA, conversion of TA into the ciphertext and CK into the ciphertext. So take the matrix, key matrix into our plain text 19 and 0, mod 26, and we will get MF as the ciphertext. Same CK, convert it, apply the same procedure, we will get IO. So the our ciphertext is FKMF IO. FKMF IO for the letter attack. This is the encryption process. Now we will see the decryption process for the same. Now this is this ciphertext we got FKMFIO, and this is our key. For the decryption, the formula is K inverse C mod 26. Now K inverse means we have to find out the inverse of this matrix. So to find out the inverse of matrix K, that is K inverse, formula is 1 upon determinant of K into adjoint. Now 1 upon K means K inverse adjoint of K. This K inverse is not this K inverse, this is a determinant's inverse. So it is a D inverse also, or 1 upon D, and we can write D inverse into adjoint of K. Now D inverse means determinant ka inverse. So determinant of matrix ABCD, then the formula is AD minus BC. So D is 2, 3, 3, 6. 2 into 6, 12 minus 9. 3 into 3, 9. So 12 into 9, we are getting 3. What is this? This is a determinant. Means 1 upon 3. Now we have to find out the D inverse. So the formula is, it's a multiplicative inverse. As we know, D into D inverse, if we are doing, we will get 1 mod 26. Now the value of D is 3. We have to find out D inverse congruent to 1 mod 26. Use the trial and error method, or we can use the extended Euclidean to get the inverse of 3. So 3 in 9s are 27, and 27 mod 26 we will get 1. So 9 is the D inverse, value of D inverse. So 3 inverse is 9. Now to find that, now here, so here we are getting this D inverse as 9. Now here we have to find out the adjoint of K. What is adjoint of K? Only just for the 2 by 2 matrix, change the place of D and A and give the minus sign to B and C. So 2, 3, 3, 6, change the diagonal elements and means place of that diagonal elements and give minus sign to these diagonal elements. So 6, minus 3, and 2. As this is minus 3, convert these numbers into the plus by adding 26. So we will get 6, 23, 23 and 2. So K inverse is equal to 1 upon K into adjoint of K. We got K inverse and adjoint of K. 1 upon K inverse, sorry, this K inverse means 1 upon D, that is D inverse. D inverse we got 9, and this adjoint we got this one, mod 26. Put all these values in this formula, we will get this one. Multiply each element of matrix with 9, we will get this 54, 207, 207 and 18 mod 26. Do the modular operation with each element and we will get this matrix. Now we will decrypt the cipher. So this is our K inverse, final K inverse. Now we got this as a ciphertext FKMFIO, as you remember. Now take the numbers of that. So C is our FK. So 5, 10, convert this into the numbers. Now P equal to K inverse mods into C mod 26. Take this K inverse, so 2, 25, 25, 18 into 5 and 10, this FK. So 5 and 10 mod 26. Do the multiplication and then mod 26, we will get the back A and T. So this is the decryption process. Follow the same procedure, K inverse into C mod 26 for MF and IO. You will get the plain text for that. So what if this is a plain text which we got, that is attack. We converted first plain text attack into the ciphertext, and our ciphertext we got was this one, FKMFIO 50. When we applied the decryption method, we got the plain text back as attack. This is an example of 2 by 2 matrix, key size of 2 by 2 matrix. Now we will see another example having key size 3 by 3. So encrypt the plain text, safe message. Now here see our plain text is bigger, safe messages. This is our full plain text. And the key is ciphering. Count the letters 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 letters are there. It means our matrix is 3 by 3. Our key matrix is having the size 3 by 3 matrix. Okay. So we have to convert this safe message also into the 3 by 1 column vector or columnar matrix. So divide this plain text of three alphabets. So first is SAF, convert this into the numbers. Another is EME. Now remove this blank space. So we will get EME 4124, SSA and GES. So this is our plain text of 3 by 1 each vector. And key is ciphering. Write down this into the form of the matrix of 3 by 3. Convert each alphabet of the key into the numbers by using this. Now, the formula for converting plain text into ciphertext is C equal to K into P mod 26. As we know, encryption is easiest process. So take this matrix, key matrix as it is. Take one columnar vector and do the matrix multiplication, then mod 26. We will get the ciphertext. This is a simple procedure for the encryption. So we will get HDS as a ciphertext for the essay. Follow the same method to convert the next 3 blocks, and at the end we will get this ciphertext for safe messages. And here you can see our message was SAFEMES AGES. Now this is our message. Okay. Now here you can see this S is converted as H. S is here converted as A. So it means here also with the different alphabets, it means the occurrence of S is many times, and at each time it is converted in different letters or different alphabets. So it is known as the polyalphabetic. This is called as the polyalphabetic. And as it converts more than one alphabets at a time, here it converts 3 alphabets at a time. In previous example, we saw it converts 2 alphabets at a time. So it is known as the block cipher. Now we'll see the decryption process for this one. Now this is our ciphertext. So convert this ciphertext into the 3-3 pair. So HDS first pair, then IOE like this, and convert that thing into the numbers. The formula for decryption is P equal to K inverse C mod 26. Now we have to find out K inverse. As we have the C ciphertext, we have to find out the K inverse. The formula for finding out K inverse, which is a matrix, is 1 upon determinant of K into adjoint of K. Now K inverse means 1 upon determinant of D into adjoint of K, that is D inverse into adjoint of K we have to find out. The matrix is 3 by 3. So the formula to get the determinant of 3 by 3 matrix is, if these are the denoted as the alphabets, then the formula becomes, so first element A, then left the row and column of that A and take the remaining alphabets or numbers and its determinant. minus B, left this one, and then DI and HG, take this one, plus C. So this is the formula, or you can remember like this: A into EI minus FH minus B, just left this row and column, then DI minus FG plus. So here A, then minus, then plus C, PH into GE, and find out this determinant. So this is the formula to get the determinant of 3 by 3 matrix. Put the values of this our key matrix, calculate the determinant, and here we are getting the determinant as 1, 2, 4, 3. This is the determinant. Okay, but we don't want determinant, we want the inverse of that determinant. So use the 1243 into 1 mod 26, then 2 by, then by multiply by 3. If we are doing this method, then we will get 1243 into 5 mod 26 as 6215, and its the value is 1. So the inverse of this 1243 is 5. So the value of D inverse is 5. Now the next is we have to find out the adjoint of K. We got this one, D inverse we got, that's 5. And now we want to find out the adjoint of K. Again, for adjoint of K, use this method. A, for this element, just EI minus FH. Then for this element, leave this row and column and take the diagonal elements multiplication and minus within that. So DI minus FG. Like this, do this, write down these elements first, and then plus minus plus minus plus minus means alternative plus minus, put it and take the transpose. So here take the our original element, this is determinant, write down these values, give the sign, and then take the transpose. So we are getting these values, do the multiplication mod 26. So at the end we will get this value as a K inverse. So this is our K inverse. Hope all of you are understanding. So 5 into 197, then 5 into 147. So 735, 380, with this we are getting this one. Okay. So now see here, before the multiplication of by 5, we make it the transpose of this. So minus 1 in 97, then 94 comes here, 59 comes here. So take a transpose. So remember there is a transpose here. After multiplication also you can take a transpose, no problem. So make a transpose, then mod 26, and then at the end you will get the K inverse. So this is our K inverse. So I think it's easy method, only this we learn in the school, so we can remember how to find out the adjoint of K. Now we have the inverse, we have the adjoint, so we will get the K inverse. So K inverse is equal to, now as we already multiplied by 5, so K inverse we got here the K inverse. Now the next is put that value of K inverse into the formula to convert the cipher text into plain text. So K inverse into C mod 26 is our formula. Take the K inverse, then C, that is our first block, that is 738. This is a cipher text. Mod 26, do the multiplication, mod value 26, and at the end we will get the plain text back. So our plain text is SAF. Follow the same method, we will get the remaining plain text back in the form of the blocks. So plain text, we got safe messages. Hope all of you understood this one. Method of converting plain text into the cipher text, and again back to the plain text. So encryption and decryption by using a Hill cipher of 2 by 2 and 3 by 3 key matrix. If you have any doubt, free to ask me. Thank you all.